Hey everyone, Miss Go Electric here. Today I'm at the North American Battery Show. This is where all the suppliers come together and they show off all of their EV technology that goes into vehicles. Not only that, but there's also some energy storage solutions. So I'm gonna go inside and we're gonna find the top 5 coolest and most interesting things at the show. Let's go. This event coverage of the North American Battery Show is brought to you by UHY. Please join me as I discuss challenges and opportunities in the EV space and more at the UHY Electrified Automotive Supplier Outlook, live from N1 Concourse in Pontiac, Michigan on October 18th, 2023. Click the link in the description or visit uhy-us.com for more information. We're at Our Next Energy and they have a really cool booth here. We walked past the Baker Electric that they have on display, but we're gonna learn a little bit more about what else they're doing here, if there's anything new. I'm here with Nick Twerk. He's in charge of the marketing division here at Our Next Energy, and he's gonna tell us what's going on here at their display.
Well, we have a really exciting development here. It's our Aries Grid product, which is a 3.5 megawatt hour stationary storage system that'll be used for enabling renewables on the grid, so wind and solar power.
Very cool. So give us an idea of do you have anyone that's already starting to purchase these things from you guys? Because you're still kind of in the startup phase a little bit.
Yeah.
You're deploying a huge manufacturing facility here in Michigan, right?
We are, and actually our first customer is Berkshire Hathaway Energy Renewables.
Oh, interesting.
Yeah, we have a project we're partnering with them on in Ravenswood, West Virginia, in coal country. So we're actually, we're going to be powering a titanium smelting facility that Berkshire, another Berkshire company, is partnered with them on.
So what's the status of the manufacturing facility here?
Well, we're making Aries packs, so that packs that go into this grid container are made here in Michigan already at Piston Automotive on a line here in Van Buren Township. And then our cell factory, One Circle, that'll go online later this year for the first pilot cells, and then next year we'll be in regular production.
Getting close.
We are.
Now, last year you had a BMW or two on display, I can't remember, but do you have any other partners that have decided they want to integrate the packs that you've been showing off for the future? Have you announced it yet?
Well,
it's a tight lip.
We have many new customers. We don't have any other automotive customers that we can announce. Obviously, the partnership with BMW has been great. We're going to have some news soon on the Gemini project that we worked on with BMW to integrate the Gemini technology into a BMW iX. On the commercial vehicle side, we actually have 14 customers signed up there, so that customer base continues to grow.
Have you found that there is a great interest of energy storage at charging stations from a customer base that's communicating with you?
Yeah, actually that's another area that we see a lot of opportunity is to use this grid storage container to help enable DC fast charging, improve performance in the field. So we think there's a big opportunity, as part of the infrastructure deployment that's going on, to help provide more energy than is available, from the grid directly to charging.
And there are a ton of incentives around this whole industry right now. Are you able to capture any of those for?
Absolutely, and that's one of the things that makes an American-built grid scale storage product like this so appealing, is that it takes advantage of pretty much all of the IRA credits and the infrastructure tax credits that are available to the folks who deploy this energy storage system. So that really helps lower the costs, which makes a lot of projects viable that might not have been otherwise.
True. Well, this is really cool to see what you guys are up to, and we look forward to hearing more news by the end of the year.
Great.
But thanks for spending some time with us, Nick.
Our pleasure.
Well, this seems very interesting what you guys have going on here. My name is Miss Go Electric.
Carlos Duarte, nice to meet you.
Nice to meet you, Carlos. Can you give us a little insight on what you are proposing here? Because I haven't heard of quark before in battery packs.
Well, it's directly from the stoppers industry, from the wine to the batteries. So essentially, we have been involved in the space business for a long time. So we are supplying shielding materials for fairing applications. And being that the principle, so if your cork withstands the re-entry from the atmosphere with very high temperature as an ablative shield, could we do this for batteries? And essentially, what we try to do is trying to look where cork could fit. And we believe today that cork can be used as a thermal pad or can be used as a cell spacer. And obviously, to enhance the properties of cork, what we decided to do was to mix it together with other products. So we do have cork that can be used together with mica, with foams, or with plywood, for example. And this is the reason why we are in today showing the product.
That's fascinating because here you have a display of all the different ways you can incorporate it. But can you tell us a little bit about like the sustainability side of this? Because I'm sure that it, depending on the use case with the combination of materials.
I think ultimately, in a perfect world, cork will have to withstand all the testing that is used for any other product. Once you are able to pass that, you are a carbon negative product, so you will improve the carbon footprint of your batteries. So cork is a carbon negative. If you go to Portugal, all the carbon forests, all the cork forests are carbon sinks. So 1 ton of cork can be able to sequestrate up to 73 tons of CO2. And of course, this is the drive behind the way we approach the market. So that's our value proposition, is to be able to bring a more sustainable product to the market, in a market that by itself, an electrical car, presumably has a better performance from an emission standpoint. And that's what we are trying to contribute.
Yeah, so what are the costs associated with using this type of material in comparison to a traditional
I think you have a wide spread of materials being used in batteries. I think cork will be a very competitive solution in our perspective. Obviously, you will have to mix cork with other materials, even to enhance more the properties. The requirements are becoming more demanding. The industry is still at its very early days. So obviously, I think there's a lot of space for improvement, but we rank cork as a competitive solution for the industry.
What are some of the ways there are advantages of using cork that are maybe not familiar to someone that is?
Yes, well, cork is like a natural foam at the end of the day. And so essentially when you put cork is going to contribute to improve your thermal insulation. On the other end, if you need, for example, imagine you have a cell spacer and you have a very stiff material that is being used. If you want like a compressible element, there is a cork which can be more compressible and can help you during the operation. On the other end, if you look, for example, you want a thermal pad between the housing and the pack, we can use, for example, we have a product that has just been developed. It's the first time which is being shown. This is a cooperation product that we have with a German company called Delignit. So essentially it's a multi-layer system where cork is the core layer. So you have a stiff product that can be easily assembled on a mechanical means. It's available on a very wide spread of sizes. And of course, because it has cork inside, we expect the carbon footprint to be better when you benchmark it with non-sustainable products.
So is cork a lot easier to work with when you're integrating it in with these products as far as manufacturing goes?
I mean, it depends, because cork is very easy to handle, but the fact is that if you do multi-layer systems, then you need to find the right technologies to mix it together. So I would say that, generally speaking, cork is a very good compromise, both from a technological standpoint as well as from a performance standpoint.
Well, it's very cool to hear that you've been in the space industry for a really long time, but do you have any automotive clients yet?
Yeah, we do. So we are in the automotive for a very long time. We used to supply all tier ones, all OEMs with sealing. Actually, we have already our first success story with cork in the electrical industry. We supplied the Spirit of Innovation, which is the fastest plane in the world. It's an electrical plane, and the thermal protection of the battery has been made with cork.
Very cool, very interesting.
So that's our first success story. We are brand new to the business.
Many more to come, right?
Hopefully, yes.
Another thing that's interesting about this is we see in the EV space that when batteries are packed, basically they're using a foam material, which in that case can be very difficult as far as recyclability goes. So can you speak to the recyclability of this product here and what the advantages of something like this would be in comparison?
Well, as you know, we can't speak for the foams, obviously, but in what cork is concerned, cork is a natural product, can be recycled, can be reused, and will obviously be reintegrated in applications. When you look at the entire battery pack, then it's a different ballgame. So you need to know exactly how to separate. I'm completely convinced that in a very short term, the industry will be able to reuse, even because you're going to need raw material and you're going to need to reuse things. So it's a must more than a trend, it's a must. So I'm pretty convinced cork can contribute. Cork, it's very easy to recycle and reuse.
Well, thank you so much and good luck for the rest of the show.
Nice to meet you. Thank you very much.
Well, hi, Steve. Nice to meet you.
Hi, I'm Lacey. It's nice to meet you.
Now, this is interesting because Lincoln is familiar, but not necessarily in the DC fast charging space.
Exactly right.
What's going on here?
Yeah, so Lincoln Electric's the world's largest welding company. We've been making electric power conversion devices as welders for 50 years or more in this type of environment. Our big thing that we bring to market is reliability. Field reliability, which we think is something that the industry needs.
Yes.
We've been doing it for a long time as welding machines. So we're taking that same technology and now making DC fast chargers.
So what is this particular unit that we see here? Is this still in the prototype phase? Or are you in production with this?
So we will be in production in November of this year. This is just the pedestal. So this is what a user would see if they came up to a Lincoln Electric charger in the wild. Behind the fence would be the actual power conversion device. So what you see here, the typical HMI screen, we're showing dual CCS1 plugs. Possible to have a CCS1 on one side, NACS on the other. So you can do both Tesla or CCS1. And then you're seeing the typical charging session. So a person would come up, grab the connector, plug it into the car. They would start a charging session, and then behind the screens, the Lincoln charging system is taking care of everything.
So are these NEVI compliant?
So this is 100% NEVI compliant. And the beautiful thing about Lincoln is we are already vertically integrated. So this system is 75% domestic content. So there's no imported components. We make everything down to the board level. So 75% domestic content is a big thing. Reliability is another big thing, and service. So we have over 1,000 field service techs already in the industry, in the US from the welder side. We're just going to leverage that same service network for the charger side.
Very smart. Now, this particular unit, what is the maximum power delivery that you can get out of this?
So 150 kilowatts, so 1,000 volts, 150 amps, or 500 volts, 300 amps. It automatically configures itself based on what the vehicle tells it needs, and the Vector controller, which we use inside, handles all of that vehicle communications.
Very cool. Well, it's so interesting to see you guys get into the DC fast charging space, and it's good because we do need reliable charging.
That's our number one thing.
Well, good luck to you. Thanks for talking
Thanks.
to Steve.
Thank you. Nice to meet you.
$46.80. Pretty cool. Well, I just walked up to Reach Cooling, and although it doesn't look very interesting, guys, this is so neat. You see this here? This is actually what's in the Cybertruck. Let me explain. 4680 batteries need cooling around them, and in a radial fashion, this is what this does. So it wouldn't normally be split open like this, but essentially what happens is they have an in and out channel where these are along those batteries, and a coolant comes through these plates all the way around to make sure they stay at an optimal temperature. That is so interesting that this is actually in the Cybertruck. And then next, there's another cooling element over here that I want to show you, which is used by CATL. They're one of the largest battery suppliers in the world. But essentially, this is another cooling plate, which will have that fluid come in and out of these two ends here and circulate through these channels over the battery pack to make sure those stay at an optimal temperature. These guys also supply to BYD, and what's different about what they're doing is they use a refrigerant instead. So this is just super fascinating. I'm glad we ran into these guys. All right, I'm at Williams Advanced Engineering, and if you guys didn't see, I did a Formula E segment just recently, a couple months ago, where we went to one of the races, but I talked a lot about Williams Advanced Engineering because they supplied the battery packs
for the vehicles there. So right here they have on display some of their integrations that they've used in motorsport, which is really neat. And we're going to find out a little bit more about what they've been up to. Michael!
Lacey,
Oh my
how
God,
are you?
So great to see you.
Good to see you again.
The last time I saw you was at Bollinger Cars and Coffee.
Yes.
What are you doing here at Williams Advanced
So,
Engineering?
well, Williams Advanced Engineering became WAE. We shortened the name. And we are the Williams that used to be the engineering spin-off of Williams Formula One Racing.
Yeah.
And we're still based on that same campus in the UK, just outside of Oxford, where the university is, a little town called Grove, and that's where we build our batteries. We build various pieces of high technology for the entire automobile industry worldwide, and we even produce and build Formula E cars. We produce the batteries for the entire Formula E racing series, and we also build the cars for the Jaguar racing team. We're very proud of that.
Yeah, it's interesting you say that because I was at a Formula E race more recently when it was in the summertime here in the United States, and we talked a lot about WAE.
Thank you for that. I appreciate
Yeah,
that.
but you guys are doing so many interesting things with so many different tendrils. So you are not only in the motorsport realm, but can you talk about some of the other things that you do? And you also were acquired within the last couple of years by a company that's in the mining division, right?
That's right. We, sort of had our happy little business doing high-tech spin-offs, but the higher tech you become and the higher volume you become, the more capital that requires. And so we actually started doing a project with a very large mining company out of Australia called Fortescue. And they are a large mining company out of Australia that mine iron, ship most of that actually to China, but they were looking to take their mining vehicles and turn those into clean vehicles before legislation forced them to. The CEO and founder of Fortescue, Andrew Forrest, has a degree in oceanography. He's a true believer in clean energy and decarbonization. So he came to WAE a couple of years ago and said, listen, I have these mined up trucks and they burn 1 billion liters of diesel fuel a year. It's just an incredible contribution, to global warming. And he said, what can I do to do that? Can I put a battery on those vehicles? And we said, absolutely. So we built a prototype battery, and then we're about halfway through that build process. And he said, I like the way that this is going so much, I'd like to talk to you about buying the whole company and completely decarbonizing my fleet and then taking that to the rest of the mining industry and other industries, not just mining, but train industry, rails, you name it. And then we're going to start with batteries, but then also move into hydrogen and ammonia beyond that. So it's the big play for green energy. And as part of that, we're coming to North America.
So you're going to maybe have a manufacturing facility?
So you can tell from my accent, I'm not from the UK. I'm Detroit born and raised.
We'd love to see it.
So we are looking to manufacture in North America, and that's going to start in 2024. And we're having a very, very hard, close look at Michigan for that.
I love to hear that. As a Michigander, we'd love to see that.
Absolutely. The state loves batteries. We love the state. So stay tuned for further news in that area.
And there's a lot of incentives, so I'm sure that's a big reason why WAE is coming, right?
There's not just incentives at the state level, there's incentives at pretty much every local level that we look at, and even the federal level with the IRA Act is really taking companies like us and making us feel welcome in the North American market. So very exciting.
That is exciting. Now, I've seen those mining vehicles, and they are absolutely massive.
They are massive. There's a stairway to go from the ground into the cab of the vehicle, and you walk up in front of the vehicle's radiator up about 20 steps just to get into the cab.
So you put batteries in those?
So the very first one with the battery is running in Western Australia as we speak, and it's with our battery.
How big is that battery?
That battery is big. It weighs 20 tons. We believe it's the biggest battery that's ever been put on a rubber-wheeled vehicle anywhere in the world. Battery like that, the very first prototype that we've done, it's 1.4 megawatt hours.
Holy smokes.
And it's 1,500 volts. of energy
Wow.
coming into that mining vehicle. The technology that drives that vehicle is automated driving, so it's a true
Interesting.
innovative type of vehicle that's able to haul ore from the mining site to the railhead without human intervention, and doing so on clean green power.
Thank you so much for taking
Lacey, it's always a pleasure.
Great to see you again.
Please stay in touch with us because there will be news.
Yes, I'm
coming up
always
from WA.
fascinated seeing what you guys do. So thanks for spending some time with us.
Thank you for coming by.
Well, I consider myself an honorary Canadian because in the town that I grew up, I could actually see Canada right across the water. And this booth is so cool because this is kind of a test bed of all the technologies and abilities that Canada has to offer to put together for the automotive industry, and in particular, EVs. So they have the Project Aero on display here, which is so cool. Let's take a little bit closer of a look. All right, this here is Project Aero, and essentially what this is a combination of the Canadian supply chain in one visual. It is like a concept, but it's really cool to see them promote because many people don't know that the Canadian supply chain business and manufacturing is very popular. There are companies like big automotive OEMs that have manufacturing facilities there, even companies like Magna who do quite a bit of work in that market. So really neat to see that they're trying to promote the industry as a whole in Canada. Well, hi there, Dave.
Hi, Miss Go Electric.
Nice to meet you.
Nice to meet you
Now,
too.
I stumbled over here because I just saw a 4680 in another booth that Tesla is producing. And what I understand is that there are probably a lot of people that come from Maxwell, who is acquired by Tesla to produce those batteries. And I think probably some of you guys are from there as well. But what's interesting is that those batteries that are being produced have an anode that is dry. And it looks like to me that you guys at LeCap are producing a cell that has both a dry anode and cathode. Is that right?
This is correct, Miss Go Electric.
So can you tell me what are the advantages of going in this direction?
Right. What I can share with you today is when you buy an electric vehicle today, you buy a Rivian, a Tesla, whatever electric vehicle, 30 to 40% of the cost of that vehicle is the battery pack itself. So the cost of that battery cell is a major cost driver for every EV vehicle out there today. Within that battery pack, there is the battery cell itself, which composes of the anode and the cathode. LeCap has successfully demonstrated and producing and demonstrating to multiple customers around the world a dry electrode process for both the anode and the cathode that provides higher energy density, higher power density, lower interfacial resistivity, and an overall lower cost of 15% over a wet slurry process. So just to give you in terms of what that means, if you're a battery manufacturer, having a 1 gigawatt hour production equipment in your facility, if you transferred to the LeCap process, you would save $15.5 million per year per 1 gigawatt hour. So if you're looking to compete in the future with overseas manufacturers or to drive the cost of that electric vehicle lower in the future, this is the way.
Do you have facilities here where you are processing them?
We are located in Sacramento, California. We produce ultracapacitor materials, and we're producing these samples of anode and cathode materials. Later on in late 2024, we're going to have a 1 gigawatt hour production facility located in Sacramento for demonstration purposes.
For the product that you are delivering to customers or plan to deliver to customers, how would you say this is future-proof?
So, a good question. So basically, we are chemistry agnostic. So whether you're doing lithium iron phosphate materials, which are very popular right now, particularly in the energy storage world, nickel, magnesium, cobalt materials, NMC materials, our process is chemistry agnostic. So we're able to utilize our activated dry electrode process across different chemistries. Where we are future-proof is, as you know,
the industry is moving towards solid-state battery technology. So currently today we have a number of customers. We're actually developing we're developing materials for solid-state batteries in-house. Still at the early stages, but very good early successes that we've demonstrated to customers as the customers are coming back saying, I want more. I want to optimize the particular process. So we feel very good that, in addition to the current technology, solid-state battery technology in the future, we are well covered.
Awesome. Well,
Okay.
Very interesting. Thanks for sharing the perspective.
Thanks, Nisco Electric.
Yes, we
Pleasure.
wish you all the best of luck.
Thank you very much.
Well, that's it for the battery show this year. I hope you guys found this as interesting as I did. And thank you for watching this video. Until next time, drive, fly, ride. Go electric.